Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to your own channel Technically Explained. Hope you all are fine and enjoying good health. Today we are going to design a circular microstrip patch antenna. And the dimensions of the circular microstrip patch antenna are the following. The width of the substrate denoted by capital W will be 10th or the width of the ground plane. Length of the substrate or the ground plane denoted by L will be also 10. Height of the substrate, because we are going to use Rogers RT Deroid 5880, so the height of the substrate will be 0.7 at 7 mm. The height of the patch or ground plane will be 0.035. The length of the feed line will be 2. Radius of circular patch will be 3.2 and the width of the feed line will be 0.3. So let us jump onto the CST Microwave Studio and let us start designing. So in CST I am going to select new template and then I am going to select microwave and RF and optical and then antennas and click on next. Planar antennas, time domain, I'm good to go with the units. The frequency I'm going to select will be 20 to 35 gigahertz. I'm going to design a circular patch antenna for 5G application and I want the far field to be defined at 28 gigahertz. So I'm good to go. I'm going to click on finish. So now my CST environment has opened. First of all, I need to design my ground plane. So I need to go in the modeling and then I need to select brick. And then I'm going to press escape and now I can define my ground. So I'm going to name it as ground and I'm going to give it dimensions, which is minus W by 2 till W by 2. Because the width of the ground is W, so it should be extended to minus W by 2 to W by 2. Similarly, the length of the ground is minus L by 2 to L by 2 and the height of the ground must be T. Let me name it as small t and not capital T. Okay, I want the ground to be made of copper, so I'm going to search for copper here and then I'm going to load the copper material. So I'm going to click on preview. Now this is because I haven't defined the parameter, so I can define it here. So the width of the ground plane at the substrate must be 10 and the length of the ground plane will also be 10. And the height of the patch or the ground plane should be 0.035. So now I'm good enough to go. Now I have my ground design. The other thing that I want to do now is to design a substrate. Again, I'm going to name it as substrate and the dimensions, the length and width of the ground plane and the substrate will be equal. I'm going to give the same values in the y and x dimensions. And the height of the ground plane, this should start from t and it should be t plus h. Again, I haven't defined h, so I will define h later on. I want to load the material from the material library and search for Rogers RT Deroid. So here we go, we have the Rogers RT Deroid 5880 and now I'm going to load it. And I click preview, it is going to ask me about the height of the substrate, which is 0.787. So now I'm good to go. I'm going to click on OK. Now the next thing is to design a page, which is circular page. To design a circular page, what I'm going to do is that let me go to the front view. I'm going to click on pick face and I'm going to pick this face. And then I am going to align the local coordinate system on this. Now we have local coordinate system aligned in the center of this substrate and on the top of substrate. So now I am going to click on cylinder and I am going to select circular cylinder. And then when I press escape, circular cylinder will be selected. I can name it as circular page. Now the outer radius must be r. I haven't defined r, I will define it later on. And the height of this page must be the same, which is t. Because this is on the top of substrate, so the height I should give it t and I am going to collect copper over here. When I click on preview, this is going to ask me the value of R, which is 3.2. I'm going to click OK, and then I'm good enough to go to, I'm going to press OK. Now if you can have a look, you can see that our ground plane, our substrate in our page has been designed. Now all we need to do is to design a feed line. So I'm going to get rid of this local coordinate system, and I'm going to select the feed line. To design a feed line, I need to select the uh, bottom part of the substrate, and in the middle I need to select the substrate. So I'm going to pick point, and then I'm going to pick the center, and now I'm going to align the local coordinate system on this center. When the local coordinate system are assigned on this center, again I'm going to select a brick, press escape. Now I'm going to design a feed line. So feed line, the width of the feed line should be WF. So it should extend from minus WF by 2 to WF, and V minimum is this thing which will start from 0 and it should extend till LF, which is the length of the feed line. And again this should be the of height T, and it should be made of copper. So can we in the preview, WF is 0.3. Fine, so I can press OK, and LF is 2. So now I can press OK, and as you can have a look, we have now, you see it, we have now, let me get rid of this local coordinate system. We have now the feed line also designed. As you can have a look, the feed line is penetrating the page. Fine, so what I'm going to do is that I'm going to add these components. I'm going to add feed line. I'm going to click on boolean, and I'm going to add it with circular page. So now this has been added. Again I'm going to go to the front view, and now our component is ready. Now all we need to do is to provide it a port. Okay, now when I have designed my H antenna, I am going to design my port. I'm going to readjust it, then zoom it. Now I'm going to pick face, then I'm going to select this face, and then in the model, in the simulation, I'm going to click on waveguide port. And now I am going to define my feed line, which extends from minus 3 star WF to 3 star WF, where WF is the width of my feed line, and this should be H plus T, where H is the height of the substrate, and this should be 4 star H. Now we are good enough to go, so then can readjust it. Now our port is also designed. So let us start the simulation. Now we will start simulation, and this is going to take few minutes. I'm going to pause a video here, and then I'm going to resume it. Okay, so the simulation is complete. Now we are going to check the 1D results. In the 1D result, first of all, I'm going to check the S parameter. And now as you can have a look, the antenna resonates at about 27.9 gigahertz, which is around 28 gigahertz. And again the bandwidth of antenna is around this, which is 27.23 or something, starts from 27.23 and ends at something like 27 28.7. So this is my S11 results, and the VSWR result can also be seen from here. And then we have the far field results. In the far field we are going to check the gain at 28 gigahertz. The directivity is 5.75 dBi, and the IEEE gain is 5.48 dBi, which means the efficiency of antenna is very good. I can also check the 2D, the Cartesian, and the polar plot. So this is how we can design the circular microstrip patch antenna. If you like my video, please subscribe to my channel Technically Explained. Thank you.